Hi, my name is Abdul Saeed. This is my video presentation on cross-curricular learning in specific relation to maths and science. I'll be looking to answer some key questions. What is cross-curricular learning and how is it connected to maths and science? How does the current government view cross-curricular learning? And how can we use cross-curricular approach in a real classroom to teach maths and science together? But first, let's look at the current climate we live in today. When we look at the world children are growing up in today, we see that life is cross-curricular. Children will all look at the world in many different ways and have their own unique experiences of life. The world children will grow up in will be vastly different to anything we can imagine. Maths and science are a part of everyday life, from simply shopping to understanding the concept of gravity. Cross-curricular learning has been seen as a way of preparing children for an ever-changing world by relating the children's learning to real-world experiences. First, let's look at how we define cross-curricular learning. The definition, I believe, best defines cross-curricular learning as we know it today, comes from Barnes in 2011. When the skills, knowledge, and attitudes of a number of different disciplines are applied to a single experience, problem, question, theme, or idea, we are working in a cross-curricular way. So would a cross-curricular approach suit the teaching of maths and science together? When considering if we should use a cross-curricular approach when teaching maths and science, we must be careful, and Hayes in 2010 warns us, adopting a cross-curricular approach requires close scrutiny because the concept can be allocated to a variety of legitimate meanings. But the arguments for combining the teaching of maths and science has been going on for decades. So we can see that maths and science are natural partners, and to help children relate their learning to the real world, we should teach these subjects in a cross-curricular way. This view is supported by educationalist Gardner in 2004, who states, any topic of significance can and should be represented in a number of different ways in the mind. So what is the National Primary Curriculum's view of cross-curricular learning? The debate educationalists have been having about the usefulness of a cross-curricular approach has been mirrored by governments, and in this year, 2014, massive changes are occurring and a new primary curriculum will begin this September. So how does this new national curriculum approach cross-curricular learning? With its focus on individual subjects, it may seem at first that the new national curriculum is opposed to cross-curricular approaches. But when we look closely, we can see the new curriculum is supportive of a lot of the ideals of a cross-curricular approach. We see a massive focus on mathematics in the new curriculum as a core subject. And when we look at the purpose of study for mathematics, we see the word interconnected used, which is another way of saying cross-curricular. We also see a key phrase in there. It is essential to everyday life, critical to science, technology, and engineering, and necessary for financial literacy and most forms of employment. This would be very difficult to accomplish without teaching maths and science using a cross-curricular approach. Now let's look at the aims of mathematics in the new national curriculum. We see that another key phrase is in there, which is very supportive of a cross-curricular approach, which is, they should also apply their mathematical knowledge to science and other subjects. So the need to combine maths and science in our classroom is undeniable and will become a requirement starting this September 2014 for all primary school teachers. So we can clearly see a cross-curricular approach undoubtedly serves a valuable purpose in drawing children's attention to the links that exist between components or subject areas. So how can we approach maths and science in a cross-curricular way in the real world? Well, Barnes in 2011 lists 5 different ways of organizing cross-curricular teaching and learning, which he identified through using data from recorded lesson observations over 5 years and his own experiences. These are hierarchical, multidisciplinary, opportunistic, double focus, and interdisciplinary. Hierarchical cross-curricular learning methods aim to achieve progress in one discipline by using aspects of another. If you see the diagram that I'm drawing, you see that learning in subject A, or the superior subject, is enhanced with help from subject B, or the inferior subject, thus enhancing subject A. If we look to use this approach to teach maths and science, we would, for example, have maths as subject A and science as subject B. This would enhance the children's maths knowledge, But the drawback is, as previously stated, subject B, which in our example is science, would not be developed as well. If using a multidisciplinary cross-curricular approach, this aims at using a single experience or theme to develop higher levels of understanding and performance in more than one discipline. If you look at the diagram drawing, you see that discrete learning in 2 or 3 subjects is enhanced by arising from a shared meaningful experience. If we look to use this approach in teaching maths and science, each subject would be developed individually and brought together through a shared experience or theme, but the subjects themselves would not be combined. The weakness with this, in particular to maths and science, is that you can miss vital links which overlap in knowledge, which could help to develop both subjects. If using an opportunistic cross-curricular approach, this aims at allowing children to dictate the depth and direction of disciplinary learning in a number of subjects related to a shared theme or experience. The teacher exploits unpredictable and childlike learning opportunities arising from a powerful shared experience. In this approach, we would not look to specifically develop maths or science, but rather let the learning develop itself naturally. This approach fails to address progression or assessment, which would be very difficult if learning is unpredictable. The double-focus cross-curricular approach attempts to promote a balance between experience-based and disciplinary opportunities for learning. If we look at the diagram, subjects are taught individually and then brought together in a cross-curricular way through shared themes or ideas. With this approach, maths and science would be equally taught with other subjects in the curriculum and then brought together later on. Maths and science would be taught individually, and the shared experience itself would be what brings the subjects together. This approach would be very difficult to put into practice under the new national curriculum with its major focus on literacy and mathematics. Interdisciplinary cross-curricular teaching approach uses progression in 2 or more subjects together with the promotion of creative thinking and connection making between the subjects involved. If you look at the diagram, learning in 2 subjects is taken forward as a result of a shared learning experience and then brought back together in a presentation or application to be shared at the end. This is one of the most commonly associated approaches to teaching in a cross-curricular way. If using this to teach maths and science in a class, maths and science would be combined to explain, understand or express a particular experience or to solve a problem. The learning is then brought forward at the end of the class in a presentation of some sort. This would also allow the teacher to assess the children's learning and knowledge of maths and science at the end of the class. For this approach, the teacher must be secure in their subject knowledge in maths and science in order to successfully bring them together. So we have seen the different approaches you can use to teach maths and science in a real classroom. Now let's look at some of the ways cross-curricular approaches to maths and science are being utilised right now and the support available to teachers. Interdisciplinary learning is being promoted in Scottish education right now, and in a guide to practitioners in Scotland, they are provided with info on how to implement an interdisciplinary approach in their classrooms. We also see that in Northern Ireland, the curriculum was revised in 2007, which moved away from structured single subjects and instead areas of learning, focusing on a cross-curricular curriculum. We see that across the world, cross-curricular approaches to maths and science are being promoted. In the UK, we see many projects promoting a cross-curricular approach to maths and science, with one of the biggest being the STEM programme. STEM teaching looks to enhance and enrich the curriculum by collaboration between all subjects and links to the real world and children's experiences. The government has identified STEM education as a major priority in schools, and even in the US, President Obama has pushed STEM education with grants aimed at improving teaching in maths and science. We see lots of resources to help teachers with STEM teaching, and the National STEM Centre.org provides useful resources for primary school teachers looking for support. We also see the interdisciplinary approach to project-based learning can be integrated within a STEM approach. We can also see the use of ICT being very beneficial in support of teaching maths and science. Using such tools such as data loggers has made scientific investigation much more accessible for children, and math games on whiteboards has become common practice. If looking at data handling with the use of ICT, we see we are using maths, science and ICT skills in a truly cross-curricular way. In conclusion, we have seen the benefits of using a cross-curricular approach to teaching maths and science in this ever-changing world. Cross-curricular learning offers a creative way to develop children's learning and connect it to the real world. Teaching maths and science in a creative way within a cross-curricular approach will help children make connections to the world around them, thus developing their knowledge further. We must remember to consider the negatives of a cross-curricular approach if considering its use in teaching maths and science. As teachers, it would be easier to plan for a single subject rather than multiple in a class. Also, we must consider the issue of assessment. If we teach children in a cross-curricular way, should we assess them in a similar way? But how do you actually measure personal growth or creativity? Making connections between maths and science has become a requirement under the new national curriculum, and all teachers will have to consider cross-curricular approaches to teaching maths and science together. But if approached properly, making cross-curricular links between maths and science will be beneficial in any real primary classroom in today's climate. Finally, I will leave you with the words of Plato, who argued for cross-curricular learning over 2 millennia ago. Anyone who can produce the best blend of the physical and intellectual sides of education and apply them to the training of character is producing harmony in a far more important sense than any mere musician.